Hello everyone, I am back again with another interesting topic in light, reflection and refraction. So today I am going to start with module 6. So here we will be discussing about ray diagrams for concave mirror. So before you start watching this video, make sure that you have watched module 5 wherein I have discussed about the important rules that needs to be followed while drawing ray diagrams. So rules are very important to learn this module. So before you start with this, ensure the rules are thorough. So let's begin with the learning objective of the day. So today we'll be drawing the ray diagrams using the rules. And also we will be discussing some important characteristics of the image formed by concave mirror when object is placed at various positions. But in this module we will be discussing only one object position. Okay, so we will discuss in detail. First object position is object at infinity. So don't worry about the term infinity. Infinity means far object. Your object is very far. Or it is also called distant object. Okay, distant object. And this method, we use this method to determine the focal length. Okay, focal length of a mirror or a lens, anything. So here object means what? It can be anything. It can be a tree, it can be a pencil, it can be a pen, it can be a building. Since we are talking about infinity, we take any object which is very far from you. So usually we represent an object by a line with upward arrow. So diagrammatically this is how we represent an object. But here in this case we don't use this to represent the object because our object is very far. And we also know that the rays coming from infinite objects are nearly parallel. So here we use only parallel rays of light because our object is at infinity. So let's begin. Draw the mirror. So we are using a concave mirror and make sure that your reflecting surface of the mirror. This is the reflecting face of the mirror. Reflecting face of the mirror should face towards your left side. And draw the principal axis. Label all the important points. Okay, pole of the mirror, focus and center of curvature. And one more thing you have to keep in mind while drawing this or while labeling these points on the principal axis is that this formula R equal to 2F should be satisfied. That means from here to here and from here to here the distance must be equal. Suppose if you are taking this as 1 centimeter from pole to the focal length, focus, if you are taking it as 1 centimeter and from focus to center of curvature also your distance should be 1 centimeter. Okay, if your measurements are proper then you will get the image at the right place. So that important point you should keep in mind. Okay, yes. So I told you that we will be applying the rules when we draw the ray diagrams. So here since object is at infinity, I am using only the first rule, that is parallel to principal axis. Okay, so it is coming from infinity. This parallel rays are coming from infinity. So I am not showing the object here, which this ray indicates it is coming from infinite. Okay, so what is the first rule? A ray parallel to principal axis, then after reflection it will converge at focus. So I am using two parallel rays, one above the axis and another one is below. This is also incident ray which is coming from infinite object. Then it hits the mirror. Okay, here you can see it is hitting the mirror. Then after reflection it will meet at F. Suppose if you are focusing on a distant tree. Okay, we have a big tree which is very far. Now the rays coming from this tree will meet at this point. So you will get the image of this tree at this point. Since the reflected rays are meeting in front of the mirror, this is the reflecting face of the mirror. So the reflected rays are meeting in front of the mirror. Since they are meeting in front of the mirror, your image will be inverted. So you will get inverted image of the tree at this focal point. And this image will be very small, or we can say point sized. You will get very small size of your tree here. Got it? Now let's see what are the important characteristics of the image formed. Yes. So whenever I say image characteristics, these are the three things you should tell me. That is nature, size and position. What is the nature of the image? Real and inverted. Why it is real and inverted? Because reflected rays. This green shows reflected rays. Reflected rays are meeting in front of the reflecting surface, in front of the mirror, or you can say in front of the mirror. That is why it is real and inverted. Now what about the size of the image? Yes, I told you it is point sized. Point sized, or we can say highly diminished. Highly diminished means very small. Diminished means small. Highly diminished is very small. Now what is the position of the image? Where are you getting the image? At F. You are getting the image at focus. So this is the first object position. Now tell me, where are we applying this object position? We are using this object position in our real life situation. Let's see, where are we using this? Yes, have you noticed this? Have you seen this anywhere? This is a solar cooker. Okay, so here see, this is the curved, this is a concave mirror shape, this is a curved mirror, and sun, this is the sun which is very far. Sun is at infinity. So the rays coming from infinite objects are nearly parallel, so they hit the mirror and they converge at this point. So sun can produce very high temperature. So if all the rays are converging at one point, then the temperature will be very high. So you'll get very high temperature, which is enough to cook a food or boil a water. Okay, so this is one of the applications of this object position. So we will meet again with the next object position in our next video. Till then, bye.